Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make the channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into validation in the world by large. Thank you very much for your precious time. Before my lecture, I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilma. Oh my Lord, open my chest and ease my task for me, and loose honor from my tongue that they may understand my saying. Allahumma Rabbi zidni ilma. Oh Allah, advance me in my knowledge and true understanding. Okay, today I'm going to discuss my lecture number 8. Fluid catalytic cracking FCC unit. Warning a pathway, delivering on commitment, differentiated performance, enabling profit optimization process. Lecture number 8. Lecture number 8, key takeaway points. Fluid catalytic cracking FCC unit. Lecture number 8. FCC unit, major equipment, function and purposes. Okay, key takeaway points. Lecture number 8. Today we are going to discuss reactor regenerator section. Number 1. Catalytic storage hoppers, main air blower, regenerator assembly, cyclones, catalyst cooler, orifice chamber, and a flue gas slide wall, catalyst stand pipe and slide well, reactor assembly. So these are 8 topics we are going to discuss next couple of days. Okay, catalyst storage hopper. The FCC unit is built with 3 catalyst storage hoppers. One is for a fresh catalyst, one for a low metal equilibrium catalyst, and one for high metal equilibrium catalyst. Catalyst activity must be maintained during a normal operation to a level compatible with the desired mode of operation. To achieve this, catalyst is loaded to regenerator on a continuous basis and unloaded intermittently. The 6-inch catalyst movement line from the upper regenerator is normally used to withdraw catalyst during operation and shutdown. A 6-inch line to the combustor is used to load catalyst during startup. 2-inch line to the upper regenerator is used to continuously load a catalyst during normal operation. Air from the main air blower is used to pressure up the hoppers as this air is hot and dry. To fully pressurize the hoppers, instrument air is used. Used air must be free of any water to prevent formation of mud. The catalyst loading lines have frequent air pulses to help move a catalyst and to assist unplugging the lines. These air pulses are open slightly during loading and unloading process. Catalyst unloading lines are insulated in areas for personal protections but are allowed to cool off to the atmosphere so that the temperature limits on the metallurgy will not be exceeded when hot catalyst is unloaded. Valves on the loading lines have air pulses to the stems and seats to keep these areas clear of the catalyst particle and permit a smooth operation. Okay. Main air blower. The air blower is required to supply the necessary amount of air to burn the coke of the catalyst. Depending upon the mode of operations and other factors such as feed quality, the required air amounts to 10 to 14.5 kg per kg coke. This converts to about 330 to 500 Newton meter cube air per cubic meter of feed. A check valve is installed on the discharge of the air blower. It prevents a backflow of air or catalyst which could cause serious damage to the blower. Fluidized catalyst will easily flow back through the air heater if pressure is lost. If the blower starts to surge, a large amount of regenerator must be isolated from it. The check valve is a swing check valve. An air cylinder provides an assist for closing. It consists of a spring opposed by a small piston. Under normal condition, instrument air is supplied to the piston which moves up to compress the spring in case of instrument air failure to the piston. The check valve will remain open if the main air blower is serviced, but the pressure drop across the check valve will increase. Okay. Regenerator assembly. First is a direct fired air heater and air grate. Second, high efficiency regenerator and combustor. Number 3, torch or nozzles. Okay, first we are going to discuss a direct fired heater and air grate. Okay, direct fired heater and air grate. This carbon steel internally insulated vessel heats air to the regenerator if necessary. For example, starter. The burner is fired with fuel gas on a heater, discharge temperatures control. The pilot burner is it by a spark igniter. Air is directed to the burner by a large damper, controlled externally with a hand crank. Side parts are provided for flame observations. Air purged to the side ports keep the glass cool and can be used to blow catalyst out of the pots if it backs up from the regenerator. A block valve is provided to shut off the pots when the burner is not being used. The air leaving the heaters enters the combustor via an air grid to properly distribute the air to the full cross sections. The grid is designed as a pipe air grid which distribute the air through large laterals into smaller branches. It is designed for a total pressure drop 0.05 bar G. Values of 0.035 to 0.07 bar are satisfactory. Okay, next topic, high efficiency regenerator and combustor. Okay, high efficiency regenerator and combustor. The regenerator is an internally lined carbon steel vessel. The lining called refractory is a concrete top material which is sewn onto the reinforced supporting material. This lining is necessary to protect the metal wall of the vessels from high temperature at which the regenerator operates and should keep the outer shell of the regenerator below 343 degrees Celsius at all times. Pressure taps and pressure tabs used as a level indicators are protected by instrument air purges. The purges provide a buffer between the catalyst bearing as in the regenerator and the small instrument tabs which can easily plug. Connected lines which are also in hot service are refractory lines as well. The high efficiency regenerator approximate a plug flow burning profile from the catalyst. The spent catalyst from the reactor mixes with the blower at the roughly an equal amount of recirculating or cooling regenerator catalyst at the bottom of the regenerator combustor. The re-recruiting flow of the catalyst is necessary because the spent catalyst at 495 degree to 550 degrees Celsius is not hot enough to initiate and complete burning in a reasonably sized vessel. The mixing takes place in the lower part of the regenerator called the combustor. The coke burns off the catalyst and it travels up the combustor riser with air, there is a rough idea about how it can be implemented. Okay. Okay. The mixing takes place in the lower part of the regenerator called the combustor. The coke burns off the catalyst as it travels up the combustor riser with the air. There is enough separation at the top of the riser through a T-shaped outlet. The flue gas goes up to a two-stage cyclone system and auto energy recovery. The catalyst settles to a dense phase from here to flow spill, part of the catalyst going to base of the reactor rises and the rest back to the combustor. The flue gas leaving the dense bed of the regenerator will carry off the smaller catalyst particles with it. Some of these settle back to the bed, others are carried higher. Okay, before the flue gas leaves the regenerator top outlet, it passed a system of two-stage cyclone where most of the remaining catalyst is separated from the flue gases. Okay, torch oil nozzle. The combustor is equipped with torch oil nozzle. They provide a means of injecting heavy oil into the dense bed with extra heat is needed during startup. The oil is separated into the regenerator with automatic steam. When no torch oil is injected, a small amount of steam is to the annular space around the nozzle and through the nozzle to prevent any catalyst build-up and to cool the tip of the torch oil lens. The torch oil nozzles are installed in a position that the regenerator wall and nozzle to be protected. Okay, thank you very much for your precious time. Next, my slide is for the key takeaway points: catalyst storage hoppers, main air blower, regenerator assembly. We have discussed direct fired heater and air grid. We have also discussed high efficiency regenerator and torch oil systems. First will be cyclone, catalyst cooler, orifice chamber and gas slide wall, catalyst standpipes and slide wall, and reactor. Okay, please do not hesitate to send me your feedback, chemistry.masood.dear@path.edu. Thank you very much for your precious time. Okay, these are references.